Hello everyone, welcome to another session on C++. Today we are going to understand what does swallow copy means and why do we need to overload the copy constructor. So let's start our coding by just creating a class. So I'm just going to use the default header.h file that we have, and I'm going to just create a class here. So my class name is A, and I'm going to have a data member called as int star p. I'm going to put it into public scope so that it will be very easy for me to access it in the main class. Then I'm going to basically create the constructor and a destructor. Okay, so in the constructor, what I'm going to do, I'm going to create the memory for this, and in the destructor, just going to delete the memory. So we have a very simple class that is with us, and we are going to create a main method to basically utilize this class. So I'm going to create a source.cpp. Here I'm going to include the header.h. So I'm going to include this. Then I'm going to have my main function, which is essentially going to return me 0 with success. Okay, let me try to access the class that I have written. So let me have it created like aob1. The moment I'm going to write aob1, I'm going to basically touch my constructor that I have written over here, and my p will be initialized with some memory. Now next line I'm going to do is I am going to create another object. Okay, before creating another object, I'm going to assign some value to the pointer that I have created. So I'm just going to do like this, star equals to 5. Now what we'll have is, now the p value that I have is going to hold the address, and the value that address points to is 5. Now let me just try to create another object here, ob2, and that is created out of ob1. So what we are going to do is, we are going to copy the value which is there inside ob1 to ob2, and you can see there is no compiler error here. That means compiler is ready to accept that this is an acceptable line. So why is it so? Because we didn't overload the equals to operator for the class A. That means the class A is already having a default copy constructor. Now what is the purpose of the default copy constructor? So the purpose is just to blindly copy the content of ob1 into ob2. Now what does ob1 have? ob1 holds an address, and that address is basically int star. Now that int star will be blindly copied to the ob2. Now the problem is, whenever you are going to make changes to ob2.p, it is going to be reflected into ob1.p, because essentially both are the same address. Let's try to debug it and then confirm. So let's try to start the debugger. Now we are going to create object. So I'm going to put a breakpoint here, which will say that I'm going to press F5. So now I'm going to assign one address for P. Yes, one address has been created, which is ending with 5330. Now let me show you that ob1 has been updated with the value 5. You can see here 5 has been updated over here, and the address is 5330. Now with this line of code, as I told, ob2.p is going to hold the same address, which will be pointing to 5330. Let me just press F10 and then show you that. Look at this. I never put 5 into the ob2. So who has put it? So basically what happened is this 53C0 that you can see here is copied from ob1.p. Now that is threatening, because the moment I am going to change the value of ob2.p, it is going to reflect on ob1.p. Let's see that. So I'm just going to write a small line of code so that you can understand. So ob2.p, I'm going to let me change the value of ob2.p to 10. And I'm going to write it into the console. So let me just type ob1.p. Let me add the IO stream so that we can use the cout. So as include IO stream, then I'm going to using namespace std to it. Now what I'm going to show you is the moment I'm trying to print the value of ob1.p star, I'm going to show you 10. Now that is a problem. Let me show you that before we can discuss further. So I'm going to just put a breakpoint here. I'm going to remove unnecessary breakpoints, and I have just a breakpoint here which will show the value of ob1.p star. Okay, let me just put F10 and look at the console. This is 10. Now this is a problem, because what we have done is we have made the changes to ob2.p, but why did it change the value of ob1.p? ob1.p? The reason is the line that we have written here. The moment you write ob2 equals to ob1, a ob2 equals to ob1, what we have done is we have blindly copied. We didn't do that mistake. The mistake has been done by the compiler. Why? Because the compiler doesn't know that whether you hold an address or you hold a value. When you hold a value, you can completely trust on the default copy constructor that is given by the compiler. But when you hold an address or a reference, you should never believe on compiler, because it can have a disastrous effect. So let me try to fix this problem. Now to fix the problem, what we have to do is we are going to overload the default copy constructor that is given by the compiler. Now how to ensure that the compiler will own a default copy constructor? Now this line is the proof, but let me just show you another proof also. So I'm going to mimic the copy constructor that is owned by the compiler. So what it is going to have is, it will definitely have a const a reference ob. Okay, why did I write const here? Because I don't want to modify the value of ob, means the value that we have from where we are copying the value while creating another object. We don't want to destroy, or basically we don't want to modify or alter the value of that object. So we have given const here. The reason behind giving this a reference is I don't want to create a new memory location for the ob here, and I'm adding this delete to make sure that the default constructor has been deleted. So this is saying it is a deleted function, so you can't access it here. This confirms that we are using the default copy constructor. Now let me try to overload this by giving my own definition. So here I am going to write few lines of code where I am going to ensure the copy happens not in a blind way, rather in a way that we are going to retain the value, but we are going to create a new address for the new object that is being created. So first what I am going to do is I am going to take the backup of the value that is there in the object. So ob1.p is holding a value So I'm going to put it into a temp variable. So this ensures that the value is being retained into a variable called as in temp. Now my intent is to basically create a new memory for the P. So here what I'm going to do, I'm going to access P like this, and I'm going to create a new memory location. So new memory has been created. Now the value for this has to be the value that I have inside temp. So I'm going to assign the value of temp. So in this case, what we have ensured is the value that is there inside the OB is getting retained, but the reference or the address that is there is a new address for the new object that is being created. Let me put a breakpoint over here to show you the effect. So I'm going to put breakpoint over here and then start. Okay, we have a breakpoint inside the copy constructor. So you can see here I'm going to press F10 and the value is being copied, which is 5. Let me show you what happens for the new memory. So if you look at the P value that is there for OB, that is ending with 5B10. Now the P that is there in our space, in the class A space, that is 9368. Now this is for the new object that is being created, basically the OB2 that we have in the main application. Now these two memory are different. This is 5B10 and this is 9368, ending with 9368. Let me press F10. So now my new memory location is containing a value which is the value that was there with the ob.p star. And then let me press continue. So the same code is there in the application, so there is nothing changed, but the moment I'm going to do ob1.10, you will see the magic. You are seeing 5. Earlier you used to see 10 because ob1 and ob2 were tightly coupled because of the reference that we have with P, and the P reference or P address was connecting these two objects closely because it was a swallow copy. Now in this case what we have done is we have done a deep copy. So in this case we have ensured that only the value is being copied, but the address is created freshly inside the copy constructor, so that we don't have the problem that we had with the swallow copy. So in a nutshell, if I want to explain this, when you have a reference or a pointer that is inside your class as a data member, it is imperative for you to write a copy constructor overloaded function. If your data member doesn't contain any pointer, you can still go ahead with the default copy constructor that is given by the compiler. That's all about the copy constructor. Thanks for watching this video.